Hello, Legacy students. Marsh here. So what we're going to look at is solving systems by elimination. So this is the third way we're going to learn how to solve a system. This is the third and final way that we're going to learn to use elimination by. Your learning goal: I can find solution to a system of equations by elimination. So what you're going to hear this called is linear combination or elimination. Depends where you hear it and who's saying it. So let's kind of look at what that kind of means. So linear combination, linear means lines, and combination means putting things together. Elimination means to take out something. So basically what we're going to do is we are going to add equations together, trying to eliminate one of the variables in a specific way. That's basically what we're doing. That's what linear combination or elimination means to do. So what you're going to want to do is grab out that booklet that we made in class today, that's Solving Systems of Equations by Elimination booklet, and flip to the first page, example 1. So example 1, we have 3x plus y equals 2 and x minus 2y equals 10. This is our system. So what we're going to do is, I'm going to put my instructions over here. So the very first thing you're always going to want to do is you're going to want to multiply one or both of the equations to cancel out a variable. Okay, so you're going to want to multiply one or both these equations by a number to cancel out a variable. So let's look here. What would be the best way to multiply? You can do multiple things. What we need to do though is we need to have one positive, one negative, and they need to be the same number. So my x's, they're both positive, right? My y's, one's positive, one negative. So what I'm going to do, I'm going to cancel out my y's because it seems to be a little easier to be able to do that. So I need this. So this has a 2 here. I need this to also have a 2. So what I'm going to do is I'm going to multiply the top here by 2. So I'm going to put little 2's. Now, make sure you multiply everybody by that 2. I find some students forget to do that. So if I multiply everybody, I'm going to get 6x plus 2y equals 4 for that equation. So then what I'm going to do, my second step here, I'm going to add, that's when that linear combination comes into play, add the two equations together. Okay, so second step here, I'm going to write down my second equation. Now, what you're going to do is you're going to add these together. So, I get 6x plus an x is 7x. 2y minus 2y, well, that's gone, right? And 4 plus 10 is 14. So now, your third step, you're going to solve for the variable. Okay, so third step here. Gotta solve this equation that came out, gotta solve for it. So let's divide by 7 on both sides. I'm gonna get x equals 2. So we're almost done here. I already have a variable solved for. So then what we're going to do is substitute the value into an equation. Okay, so you're going to substitute the value into one of these two equations. Don't substitute it into this one because it's going to be a little harder of math. So let's plug into one of these two equations here. So I'm going to plug it into, let's do it to the bottom one. So this is part 4. X minus 2y equals 10. So I'm going to take my 2 and plug it in for the x, just like that. Kind of like what we did for substitution, it's just not as easy. So solve for y here. I'm going to subtract for 2. I'm going to get 8, because 10 minus 2 is 8. Let's divide by negative 2. So I get y equals negative 4, it looks like. So I got x equals 2, y equals negative 4. And we're going to plug it in to a ordered pair and be done with it. So make sure you write it as an ordered pair. All of these answers need to be an ordered pair. Let's try example 2 now. So I got 2x plus y equals 6 and negative 4x minus 2y equals 5. So let's look. What can I multiply by? So I got 2x and negative 4x, right? Well, they're opposite signs. Y and negative 2y, those are opposite signs as well. So let's cancel out our x's since we canceled out our y's last time. So 2 needs to become 4. So let's multiply by 2 to all these guys. So I'm going to get 4x plus 2y equals 12. Now let's rewrite our second equation out here. Let's go ahead and add them together. So 4x minus 4x, it's gone. 2y minus 2y, that's gone. So I'm left with 0 over here. 12 plus 5, that's 17. 0 doesn't equal 17, so this is a no solution. Because there is 0 does not equal 17. So if all of your variables cancel out, if you're left with something that doesn't work, 2 equals 5, 0 equals 3, 3 equals 5, something like that, there is no solution to the particular problem that you're working with. Alright, so let's do the last one here. I got 2x plus 5y equals negative 6, and 6x plus 5y equals negative 18. So the very first thing I'm going to do is I need to figure out what can I multiply the top equation or the bottom equation by to get something to cancel. So let's look. Do we have any that are different signs already? So I got 2x and 6x, not different signs. 5y and 15y, those aren't different signs either. So I'm going to need to multiply one of these guys by a negative so I can get a negative number. So I'm going to do that here. Let's multiply just by negative 1. So I'm going to get negative 2x minus 5y equals 6. It's still not going to cancel out if I add, right? I'll get 4x, 10y. That's not going to work. So let's multiply to get my 2 become my 6. So let's multiply my new equation by 3 here. So I will get negative 6x minus 15y equals 18. Let's rewrite our bottom equation there. 6x plus 15y equals negative 18. Now we follow our next step. Add them together. Negative 6x plus 6x, 0. Negative 15y plus 15y, 0. 18 minus 18, that's 0 as well. So 0 equals 0, well, that's many solutions, because 0 does equal 0. So if you get so that everything cancels out and you get a number or a number equals a number or 0 equals 0, that is many solutions. Basically, just like when we're graphing, that is the two lines lying on top of each other. We're going to do another problem in class together when we get back, and that's the end of this video. See you later, Sabers.